And so, Dana Nuccitelli is an environmental activist. He is an environmental scientist, a climate journalist, and research coordinator for the grassroots advocacy group Citizens Climate Lobby. He's been writing about climate change for over a decade for skepticalscience.com, The Guardian, and Yale Climate Connections. He received the National Center for Science Education's Friend of the Planet Award in 2016 for his writing on climate change with The Guardian. Dana, we thank you so much for being here as part of tUrn Week after your wonderful and well-received presentations in tUrn4 last spring. And now to everybody who's assembled here on Zoom, someday we'll be in person. We now give you Dana Nuccitelli, who will talk on hotter, drier, and on fire. Dana, all you.
All right, thanks, Barbara. Okay, so, Barbara pretty much covered all my background. Environmental scientist, climate journalist, and research coordinator for Citizens Climate Lobby. Been writing about climate change for over a decade now. I've published a few peer-reviewed climate science papers too, and a book called Climatology versus Pseudoscience. So I'm going to talk for probably about a half hour about local climate change impacts in California and the Southwest in general. And then we're going to switch over to what's going on in Congress with climate policy solutions. So first, just some general ways that climate change is connected to our worsening extreme weather events. So the basic connection is that when we burn fossil fuels, they have carbon contained within them. The carbon gets released into the atmosphere, combines with oxygen in the atmosphere to form CO2, which is a greenhouse gas, and then traps heat, therefore increasing global temperatures. And so when we have higher temperatures, one thing that does is evaporates more water from the soil. And so when there is a natural drought, because of this increased heat and increased evaporation, that exacerbates natural droughts, makes them more intense, more extreme than they would otherwise have been. Also, obviously, if you're increasing temperatures, you're making, when there's a heat wave, it makes a heat wave worse than it would otherwise have been. And when conditions are hotter and drier than they would otherwise have been, and then something sparks a wildfire in a place like California, then the wildfire spreads more explosively, further and faster than it would otherwise have. And so you also get more extreme wildfires. And so we're both getting more evaporation from the soil because of this increased heat. And also when the atmosphere is warmer, it holds more water vapor. There's this relationship that for every 1 degree Celsius of increase in temperature of the atmosphere, it holds 7% more water vapor. And so then when there is a rainstorm, because there's now more water vapor in the atmosphere, more precipitation falls. And so you get more extreme rainfall events, which then contributes to more flooding as well in regions that are prone to flooding. So for us in California and the Southwestern United States, really heat and drought and wildfires are kind of the big three climate change impacts. The Southwest is the hottest and driest region in the United States. And one really important impact is on California's agriculture, because California is a really big producer of a lot of different crops in the United States. So we actually produce 2/3 of all fruits and nuts grown in the country, and nearly all of a whole bunch of different really tasty crops: almonds, artichokes, avocados, broccoli, carrots, celery, kiwi, figs, garlic, grapes, raisins, raspberries, strawberries, honeydew melons, nectarines, olives, pistachios, plums, tangerine, mandarins, and walnuts. Almost all those crops grown in the USA are grown in California. And especially almonds, it's actually 80% of the entire world supply of almonds is grown in California. And one problem is that that's a very water intensive crop. And now we're having problems with kind of an unreliable water supply because of drought becoming more and more intense. And so that's resulting in a lot of farmers having to, or at least consider pulling out their almond trees. And almonds alone in California are worth $6 billion per year, which is kind of a staggering amount of money for one crop. But it's very valuable, and it's becoming a problem because of our lack of water. So as I mentioned, drought and heat and wildfires are kind of our main climate risks that all also impact our agricultural productivity. So on the right, this is a nice map that I pulled from a paper from a couple of years ago, showing basically everything that's not dark blue is a county in which a significant proportion of the land is used for agriculture. So basically like a light blue is 30%, and then yellow is like 60% and so on. So you can see the Central Valley in California is a significant producer of agriculture. In California, our agricultural industry produces $50 billion in revenue per year, which that's more than the entire state economies of Vermont and Wyoming, and as big as the entire state economies of Alaska and Montana. So just kind of hammer on that point of how important our agricultural productivity is. It's like as big or bigger than entire states' economies. And so the problem is, as you get higher temperatures, it starts to shift. One thing it does, in addition to exacerbating these droughts and heat and wildfires, is that it starts to shift the zones in which we normally will farm certain crops. So this is a nice map of agricultural zones. So California, the Central Valley, we're kind of this orange zone, which is kind of the it's called plant hardiness zone 9A, which is about the annual lowest minimum temperature. So as cold as it gets is about 20 degrees. But a lot of fruit and nut trees, they actually require a certain period of cold temperatures in the winter. And if it gets too hot, if it's not cold enough, it will reduce crop yields. And so in the future, if we continue on kind of a worst case scenario global warming path, then the zones shift to looking like this. So now all of a sudden, Central Valley is in this red zone, kind of the tens, where it's more than 10 degrees hotter and it's in our coldest winter temperature than we used to be. And suddenly that shifts where we can grow a lot of these crops, and it poses a really big problem for these like really big agricultural areas where we planted a bunch of citrus trees or nut trees or other fruit trees that suddenly can't. That basically their productivity decreases because the temperature is not what it used to be. So this chart is from some data from NOAA. It's kind of interesting. It's the change in precipitation across the United States over the past 30 years. It's kind of interesting. You can basically draw a line straight across the middle of the United States, and everything on the east half of the country is, see it's this green, which basically means precipitation has increased over the past 30 years. And most of the western part of the United States, you can see, is this kind of yellow-brown, meaning that precipitation has decreased, especially here in the Southwest. We've got a lot of decrease in the amount of precipitation, which basically means everything's drying out. And that's one of the reasons we're heading into these drought conditions. And so this chart shows that pretty nicely. This is from the U.S. Drought Monitor, showing basically the western section of the United States, how the drought monitor has characterized our drought status since the year 2000. You can see for most of that 20-year period, we have been at least in partial drought conditions, and it's kind of gotten pretty bad. Like you can see, the exceptional drought is the really dark red. That's kind of, so where we are right now is kind of the worst proportion of exceptional and extreme drought that we've been in this entire drought period. But over that whole 20-year period, we've been kind of in at least some kind of moderate, severe, extreme, exceptional drought category in the Western United States. And right now it's just particularly bad, but the whole 20-year period, we've kind of been flirting and into drought conditions. The question is, are we in a mega drought, which a mega drought is basically like a multi-decade drought that just kind of persists, or are we heading into a mega drought? That's kind of a question that climate scientists have been debating, because it's a little bit tricky. Like, how do you define a mega drought? Like, or is this what we're looking at here? Is that sufficient to call it a mega drought? Or is it just something that we have to worry about becoming a problem in the future? But there was a nice study about this last year in the journal Science. And basically what they looked at was historical records, looking at things like tree rings, where you drill a core into really old trees and pull out the core, and then you look at the width of the rings back in time. That tells you how much water there was available in past years, going back a really long time, as long as the trees lived. And so what they found was that 19-year period from 2000 to 2018 was the second driest in the Southwest in at least the past 1,200 years. So we are in a really, really significant drought right now. And they estimated that human-caused climate change made those drought conditions about 46% more intense than they would have been naturally. And so basically it took what would have been kind of a modest, moderate drought in the Western United States and amplified it. Climate change amplified it by creating these hotter and drier conditions, which made it, instead of just being a moderate drought, pushed into these really severe conditions so that it's comparable to the worst southwestern mega droughts since the year 800, which just to kind of put it in context, that was when the Mayan civilization was still in its heyday, so a long time ago. So in that entire 1,200-year period, we're in roughly the worst drought that the West has experienced. So that's hit California really hard, the current drought. So during the peak of the last part of the drought in 2015, we lost more than 10,000 jobs in agriculture because the agricultural industry was hit so hard that farmers had to fallow more than 500,000 acres. It cost us almost $1 billion in crop revenue in California in the year 2015. So again, the drought is really hammering our agricultural industry really hard. And so this is a nice chart from the latest Intergovernmental Panel on Climate Change report, which was just published a couple months ago, where they're kind of showing how droughts are getting more and more intense over time. Again, because when you have higher temperatures, it dries out soils and exacerbates droughts that would otherwise have been natural, makes them worse than what otherwise have been. So if you look at this chart on the right, you can see what was in the late 1800s a pretty intense drought, so intense that it would only have happened once per decade. At this point, we're at 1 degree Celsius, roughly, warming hotter than pre-industrial temperatures. So at this point, that happens almost twice as often. Now it's happening once per 6 years instead of once per 10 years. If we get to 1.5 degrees Celsius, then it will be twice as frequent. We'll see it once per 5 years, what used to be a once per 10-year drought. If we get to 2 degrees Celsius, kind of the upper end of the Paris Agreement targets, then that same drought will become a 1 per 4 year event. And if we get to 4 degrees Celsius, which is a really, really dangerous, probably catastrophic level of global warming, that same drought will happen once every 2 to 3 years, about 4 times as frequently as it used to. So again, basically just climate change is taking what used to be a natural drought and making it more intense and happen more frequently potentially than it used to. Another factor that climate change affects in California that also exacerbates droughts is that the Sierra Nevada snowpack is shrinking as temperatures rise. So both the Sierra Nevada and the Rocky Mountain snowpack melts, provide water to the southwestern region, particularly in the summer months when we're not really getting much, if any, rain. Then we're relying on that snow melt to kind of fill our rivers and reservoirs. But the snowpacks are shrinking for 2 main reasons. One, because as temperatures rise, and then when precipitation falls, more of it falls as rain and less of it as snow because the temperatures are hotter. So just the precipitation has a harder time freezing. And then because temperatures are getting hotter, then basically your spring and early summer temperatures get hotter, which makes the snowpack melt earlier than it would have in the past. And so those snowpacks just melt earlier in the year. So once you get into the summer months, the snowpack is mostly gone and it's not refilling your streams and rivers and reservoirs anymore. So far, research estimates that the snowpack in the Sierra Nevada mountains has shrunk by about 25% compared to what it was about 150 years ago. And it's projected to continue shrinking as the temperatures continue to rise. So it depends how much temperatures rise in the future, but overall, we're expecting to see between a 50% and roughly 90% shrinking of a Sierra Nevada snowpack, again, depending on how much we're able to limit global warming in the future. So as those snowpacks shrink, that makes the risk of water shortages in the Southwest increase because, again, you don't have that supply of water in the summer months when you're really getting a strain from increased heat, increased drought, and things like that. Yeah, so another place we're seeing this is Lake Mead, which feeds into the Hoover Dam and is fed by the Colorado River. So this is actually a nice image because you can see the water line where the Lake Mead used to be at that level, and now it's way down here. So first of all, the Colorado River flow, which feeds into this lake, has declined by 25%. And as a result, Lake Mead has dropped by 130 feet, so basically 13 stories. It's lost 60% of its water. And so that makes it more difficult for all these various dams to produce hydroelectricity, which is a very important low carbon source of electricity. And it's a very reliable source of clean electricity. But as we have these water shortages and shrinking of these water levels and decrease of the water being fed into these areas by rivers, then that makes these dams less productive at producing hydroelectricity. And again, as you're getting these shrinking reservoir levels, as the river flow declines, again, we're facing these threats of water shortages across all of the southwestern states. So there's already a lot of kind of negotiating between states like Colorado, Arizona, Southern California about the water coming from the Colorado River because it's already declined. We know that it's going to continue to decline as temperatures rise. So we're trying to limit how much it declines, but we still have to deal with the amount that it's declined so far and the amount that it's going to decline in the future, and make sure that every one of those states and every region that relies on water from these rivers and reservoirs has enough to meet their needs. So there's a lot of efforts going into being more efficient in water use and things like that. And then we have the forests. So the drought the last really significant part of the drought was between 2012 and 2016. We had a little bit of a break in like 2018, 2019. It got a little bit better, and now it's kind of back into severe drought conditions. So that 2012 to 2016 part of the droughts it took a really tough toll on trees in the Sierra Nevada. About 150 million trees died during that 4 or 5 year period. And overall, tree deaths in mid-elevation forests doubled from 1955 to 2007 due in part to climate change. So one thing that's happening is that as temperatures rise, as we have more of these heat waves, that puts a lot more heat stress on the trees. And then as we have increased worsening droughts, that places water stress on the trees. And then we got this issue of bark beetles, where in the winter months, if there's a really strong cold snap, it will kill off a significant proportion of the bark beetle population. But as we're getting hotter temperatures, particularly in the winters, we're not getting as cold winters. And so more bark beetles survive into the spring and summer months, and then they kill more trees. And so that's becoming a problem. So like, for example, 7% of the Western forest area was killed by bark beetles between 1979 and 2012. And then on top of all that, we have this increasing expansion of wildfires exploding or spreading more explosive than they used to, which again does not happen. It has bad effects on the forests, obviously. And actually, in the past few years, the forests in the Southwestern United States have become net carbon emitters, meaning that they're releasing more carbon in the atmosphere than they are absorbing because there have been such large and expansive wildfires. When those trees burn, then suddenly all the carbon they had stored gets released into the atmosphere. And so as wildfires get worse, that really poses this, we call it a feedback problem, where kind of get hotter temperatures and global warming causing worse wildfires that then burns more trees. It puts more carbon dioxide into the atmosphere that then causes more warming, which causes more wildfires. And it's this feedback loop that's problematic. It's also problematic because a lot of times for example, California's got a carbon cap and trade system, and part of our cap and trade system is reliant on carbon offsets, part of which are, for example, somebody will, rather than if they can't reduce their emissions sufficiently, they'll buy offsets that represent carbon being stored in a certain section of forest. And so they're basically saying, I'm going to buy this land so that these trees don't get cut down, so I'm preserving this carbon in this forest area. Well, if then the forest area burns down, then suddenly the offset does not represent an actual offset because all the carbon from the trees is put into the atmosphere, and you have an accounting problem where you're counting on this carbon being sequestered in these trees that is no longer sequestered there. And so that's a problem that is posed by carbon offsets a lot of the time, that it's really hard to both keep track of the trees that are being counted as carbon offsets. And then if you have forest fires burning the trees, then that's another problem. So this is a nice chart from the 4th National Climate Assessment Report, which is basically like the US version of the IPCC report. It's kind of the United States best climate scientists coming together and summarizing the latest and greatest climate science research, in this case, as it pertains to the United States specifically. And so this is a chart in that report published in 2018, where the yellow area here shows the cumulative area that would have burned by wildfires in the Western United States since 1984 without climate change, in a world that just like humans weren't influencing the climate. So it goes up and up because it's cumulative, meaning you're adding every year's forest fires to all the previous years. And then the orange shows the additional area that burned because of climate change, because temperatures were hotter, conditions were drier than it would otherwise have been. And so what the report concluded was that human-caused climate change has doubled the area burned by forest fires in the Western United States compared to what would have burned had humans not been influencing the climate. So we've doubled the forest area burned over the past 30, 35 years or so. So the majority of that happens in California because we have these nice forests in the Sierra Nevadas and all over the northern part of the state mostly. So this is a nice chart that I put together from data from CAL FIRE showing the acreage burns during the wildfire season in California every year from 1987, which is kind of when we have good data because we had cameras on satellites at that point through the present. So you can see like there's a lot of year-to-year variability because some years are naturally cooler and wetter, some years are naturally hotter and drier just because weather variations. But there's also this long-term upward trend that you can see due to global warming, due to the fact that the temperatures have gotten hotter and conditions have gotten drier. So you can see 2018 at the time was California's worst wildfire season on record. 2019 was actually pretty mild because we happened to have a relatively cool and wet year that year. But then 2020 shattered that previous record, more than doubled it. So in 2018, a little under 2 million acres burned. In 2020, over 4 million acres burned, so more than double the previous record. And then this year, we're looking at about 2.5 million acres. So it's it's going to be the second largest wildfire season on record for California. Quite a bit worse than 2018's, but not as bad as last year's. Mostly because last year, in addition to the kind of climate and weather conditions, we had this kind of freak dry lightning event in August of last summer, where there was like 11,000 lightning strikes across the state in the middle of August. And so those sparked a lot of wildfires. And so in addition to the already hot and dry conditions, you also had a lot of natural ignition events that triggered wildfires. Whereas this year, we didn't have as many of those dry lightning events. And so there weren't as many ignitions to worry about this year, but there still were very, very hot and dry conditions because of global warming, because of the drought that we're in. And so we still had a really bad wildfire season. It just wasn't as bad as last year because we didn't have that freak weather event this time. So this chart is also from CAL FIRE, looking at California's top 20 largest wildfires on record. If you look at the top 8, they were all ignited in the last 4 years between 2017. Mostly last year, we had a whole bunch in 2020. And this year we had the Dixie Fire that was ignited in July. That's almost contained now. So it burned nearly 1 million acres. So it was almost our second mega fire. The first mega fire was the August complex last year that burned over 1 million acres. The difference was the August complex is called complex because it was kind of a bunch of individual wildfires that kind of combined into one. Again, because you can see that's in August, that's when we had all those dry lightning strikes. So we had a whole bunch of lightning strikes that ignited a whole bunch of different fires that all combined into one mega fire and burned 1 million acres. The Dixie Fire was actually just one source. And so it's our largest single source wildfire by a long shot, because it burned almost 1 million acres. And the previous record, well, these are all complexes. The previous record, single largest wildfire was under 400,000 acres. And the Dixie Fire was nearly 1 million acres. So again, it just goes to show how bad our wildfire conditions are right now, that we're getting all these really, really large wildfires happening in such a short period of time. And this chart is from a nice paper published by a meteorologist from UCLA, Daniel Swain, where we're looking at the change in the precipitation patterns in California. So this dashed black line across the middle, it just represents the average precipitation in each month in California before humans were altering the climate. And then these colored lines, kind of the greenish colored ones, represent Northern California. The yellow brownish ones represent Southern California. And we're looking at how they have changed from the precipitation in the past in these months. And so you can see in December, January, February, the winter months, all the lines are above the black dashed line, meaning that we're getting more rain in the winter months than we used to. But the opposite is true in the fall. We're actually seeing less rain in the fall months, September, October, November, than we used to before humans were altering the climate. And the same is true in the spring. We're seeing less precipitation in the spring months than we used to. And so basically what this means, since in California, we already have this natural dry season in the summer, basically the dry season is starting earlier as we're getting less rain in the spring. And then it goes later as we get less rain in the fall. And so basically our dry wildfire season is getting longer and longer and longer as these precipitation patterns shift. And then we finally get a bunch of rain in the winter, but that's not necessarily the best thing, because if the landscape is already scarred from all these wildfires, and you get a lot of erosion and mudslides and things like that cause problems. So we do need the rain. It's just not great when the rain is all concentrated in these 3 months. So this is another chart from a paper that was just published not too long ago, a few months ago, where they're looking at how the wildfire season later in the year is becoming worse. And so we're looking at the months of September, October, November, which are months that used to not really be wildfire months, because we used to get more rain in those fall months than we do now. And we're looking at, they call it the fire weather index, which is basically how hot and dry and windy it is. Because if it's really hot and dry and windy, those are conditions for wildfires to spread further and faster than they would during calmer and cooler conditions. So basically we're looking at how many of these really, so this is the 95th percentile, which means like the 5% worst wildfire condition weather event days in the year. So looking at how many of these really extreme fire weather days are happening in the fall months, because you expect them to happen in the summer months when it's already hot. That's normal, but for these to happen in the fall, it basically means the wildfire season is getting longer and longer. And so the redder it is, the more of these extreme wildfire days we're seeing in the fall months. And so they look at 2 different scenarios. One is a world in which we see 2.5 degrees warming, which is basically a world where we miss the Paris targets, but not by too much. So it's kind of a moderate scenario. And so you can see there's a lot of red, meaning there's like 15 to 20 days of in the fall months where these regions are seeing bad wildfire conditions in the fall. And so there's a lot of this in the Sierra Nevada, in the kind of north coast, a little bit in the south coast, but not too bad. But when you get to a 4 degrees Celsius scenario, which is basically like a potentially catastrophic worst case scenario, then you can see like really dark red throughout the Sierra Nevadas, really bad on Northern California, especially along the coast, and in Southern California too. Along the coast, you see a lot of these potentially really extensive bad wildfire conditions in the fall months. So basically what this illustrates is that we are going to have to worry about wildfire seasons continuing to get worse, but how much worse is still under our control. And so, I mean, we can do better than this scenario, this moderate scenario. And even this moderate scenario is considerably better than this worst case scenario. Like we still see like worse wildfires than we do now, but it's not as bad as like this worst case scenario. And again, we can do better than this. You know, hopefully we can stay below 2 degrees Celsius, and then this picture won't look as bad. So basically the warmer it gets, the worse climate change impacts like wildfires are going to be. But we have control still over how bad it gets. And that's what we're going to talk about when we get to the policy part. So the IPCC report looked at how wildfires are worsening. And again, they're looking at fire weather conditions where it's hot and dry and windy. And basically they found those extreme fire weather conditions are becoming more frequent. And if we get to 1.5 degrees Celsius, then fire seasons basically get about a week longer than they used to be. If we get to 2 degrees Celsius, it's about a week and a half longer than it used to be. But if we hit 4 degrees Celsius, then the wildfire season becomes almost 2 months longer than it used to be. So it's a really severe impact, a really big distinction between the Paris target of staying below 2 degrees Celsius and these like really, really dangerous levels of climate change if we get to like 3 to 4 degrees Celsius of warming. So again, that's why it's really important that we stay below the Paris targets of 2 degrees Celsius and limit these climate change impacts so they don't get too bad, so that they still become, so they're still a bit physically at a manageable level that we can adapt to. And then, of course, another big impact from wildfires, in addition to the direct impact and the loss of the trees, is the smoke that comes along with it. And there's been some research recently that's found that wildfire smoke is particularly bad for public health, just because of all the stuff that's burning in wildfires. And so there's this nice chart put together from data from NOAA by this journalistic organization, Inside Climate News. And so basically looked at data of wildfire smoke exposure across the United States from this period, 2009 to 2013, when it was relatively a mild period for wildfires. And then they compared it to the last 5 years, which was a really bad time for wildfires. And so like in California, we were looking at relatively low level of smoke exposure during this time. It was kind of in the 10 to 20 days per year, in that kind of yellow to orange. And then this is what it looks like now, or the past 5 years. So now, we're seeing much worse wildfire smoke exposure across the year. Where I am in Sacramento, Sacramento is actually the worst large metropolitan area in the country. In terms of wildfire smoke exposure, we've been seeing almost 2 full months of the year during those 5 years where we've had wildfire smoke exposure. So not so great for us in the Central Valley, but really not great for really the entire western half of the United States, especially. So yeah, if you can see anywhere that's in this purple is basically close to 60 days, which is basically 2 months, 2 months of the year where we're being exposed to wildfire smoke. So really particularly nasty impact from climate change there. And then another dangerous climate change impact is extreme heat. So this map over here, we're looking at in the southwestern region. This is from, again, the 4th National Climate Assessment Report that was published a couple years ago, looking at how many days are above 9 degrees Fahrenheit or will be in the worst case scenario in 2060 as compared to how many there were in 1990. So you can see there's a lot of orange, which is basically kind of in the 20 to 30 to 40 days per year more. So basically a month more above 90 degrees Fahrenheit than there was 7 decades prior in the worst case scenario. Again, we can do better than this, but this is kind of like in the worst case scenario, this is the outcome. So again, heat waves along these lines have some really adverse impacts on public health. So there was a bad heat wave in 2006 in California that resulted in 600 deaths, 16,000 emergency room visits, over 1,000 hospitalizations, and over $5 billion economic costs to California that year. So yeah, heat waves can have some really severe impacts on the public health. And there's this really nice analysis by the Los Angeles Times that was just published a couple days ago, actually, finding that we've been underestimating these extreme heat impacts. And so basically the problem is it's really difficult when somebody dies of some kind of stress on their body that was caused by a heat wave. It's hard to attribute that stress. Like, for example, if they have some kind of heart failure or something along those lines, and they say, oh, they died from heart failure. And you don't necessarily connect that heart failure to the heat stress that they were feeling at the time. And so we tend to undercount extreme heat deaths. And so the Los Angeles Times kind of looked at excess deaths during those months where there were extreme heat waves, and found that over the past decade, California has had almost 4,000 deaths attributed to extreme heat. Those are particularly bad in 2015, 2017, 2018, 2019, when we had particularly hot summers. And so the National Climate Assessment Report looked at kind of what the worst case scenario is in terms of adverse extreme heat impacts in the Southwest, and found that in this worst case scenario, we could have 850 additional heat related deaths per year with an 11 billion economic cost. In certain areas where there is a lot of outdoor labor in agriculture, for example, you could lose 6.5% in labor hours across the year, $23 billion in lost wages in the Southwest. But if we take modest efforts to curb global warming, we can reduce those health impacts and limit those reduced wages by half. And again, that's just if we take modest efforts to curb global warming. So again, the more effort and the more successful we are in curbing global warming, then the less severe these impacts will be, and the more we can kind of blunt these extreme heat and other extreme climate change related impacts. So this is a similar chart from the IPCC report that we saw previously about extreme droughts, but in this case, we're looking at extreme heat events. So again, in this case, it's what was a 1 in 50 year extreme heat event in the late 1800s. So again, now we're here at 1 degree Celsius warmer than we were then. Now it's about 5 times more likely to happen. It's happening. What used to be a once per 50 year event, extreme heat event, is now a once per decade extreme heat event. If we get to 1.5 degrees Celsius, that same extreme heat event happens once every 6 years. If we get to 2 degrees, it happens once every 4 years. And if we get to 4 degrees, it happens almost every year. It's once every 1.3 years that we get this heat wave that used to be basically like a once in a lifetime heat wave. Now it's happening in this really worst case scenario. It's happening almost every year. And so heat waves are like the most direct consequence of global warming, because you raise temperatures, then you're going to raise the temperature of an extreme heat wave. And it's also the most severe impact of climate change. It's the one that these types of extremes increase and become the most commonplace and the most intense. So there was actually just another really good paper published about this in the journal Science again, where basically they quantified this change, that same change that we just looked at, but they're quantifying it in terms of a certain generational cohort. So as I said, it's like somebody born in the 1800s would experience this heat wave once in their lifetime. Somebody born in 1960 would experience that same heat wave 4 times in their lifetime. And somebody born today will experience that same wave 5 times in their lifetime if we fail to act on climate. That's kind of worst case scenario. If we fail in our efforts to curb climate change, what used to be a once in a lifetime heat wave could happen as much as once, or could happen 50 times. So basically once every year or two in a person's life born today, in a child's life born today. So this is a nice infographic we just put together. Our group Citizens Climate Lobby. It's kind of like my brainchild that our staffers did a great job putting together. And we're linking it to. We've got this push to try to get. We're trying to encourage President Biden and members of Congress to be aggressive in their climate policy that they're including in the reconciliation right now. So we've got this link that you can go to cclusa.org/white-house. If you go there, then you can write an email to President Biden, and then you can also write to your senators, because we're trying to make sure that they do as much as they can in the current climate bill that they're working on, which I'm going to talk about in more detail here. But first, just a couple more impacts to California. As a coastal state, we have to worry about sea level rise. So far, sea levels have risen 9 inches along the West Coast, and 200,000 Californians live less than 3 feet above sea level, which that's kind of probably about the upper limit for how much sea levels will rise this century, although there's a lot of uncertainty. But it probably won't be more than 3 feet, hopefully. And then sea level rise combined with storm surges could erode 2/3 of Southern California beaches by 2100. Again, if we don't get things under control. We have these major seaports in Long Beach and Oakland. We have international airports in San Francisco, Oakland, and San Diego that are all very low level that are threatened if sea levels rise too much. They're vulnerable to sea level rise. And we're looking at a potential of $5 billion in coastal property damages. So this is really a problem that any coastal state is facing, that there's a lot of valuable property along the coast that once you start to lose that to sea level rise, that becomes very, very costly. So there is good news that there is a lot of potential for deployment of cheap and clean renewable energy. So this is a nice map that my colleague at Yale Climate Connections, Karen Kirk, put together using data from the National Renewable Energy Laboratory. So what we're looking at here is the solar technical potential in every state, which is like both how much sunshine is falling, and also takes into account geography and topography. So like where you could potentially site solar farms. And so you can see California, we got a pretty good solar potential because we're a very sunny state. And so we have a lot of potential for creating both solar clean energy and solar jobs. Very similar story for wind technical potential. You can see very dark blue, meaning there's a lot of potential wind energy that we could take advantage of in California. And then she looked at how many jobs we actually have per amount of energy, those energy potentials. So California, you can see we're kind of one of the darker yellow oranges there, meaning that we're doing better than most of the rest of the country in terms of taking advantage of our solar potential. So that's good. We have a lot of solar jobs in California. The rest of the Southwest could kind of do a lot to deploy solar energy and take advantage of their potential for solar energy and solar jobs. In California, we're not doing as well in terms of taking advantage of our wind potential. Actually, Arizona is doing pretty well, and most of the other Southwestern states are doing pretty well. But you can see we're kind of the light blue, meaning we're not doing as well as we could, which could be because of NIMBY issues. It could be because we're not taking advantage of offshore wind potential that we're working on. We're trying to get some offshore wind in California. But also it could be that people oftentimes don't like to see wind turbines too close to them. And so they tend to throw up roadblocks. And so that's something we have to get past because we need that clean energy. All right, so now I'm going to shift to the policy stuff. But first, I want to kind of put the problem in context. So this blue line here is basically the problem in a nutshell. This is our historical carbon dioxide emissions from burning fossil fuels. So you can see kind of a slow increase as we went through the Industrial Revolution, and then it started to increase faster and faster. And then we hit kind of the end of World War II, and it really shot up as economies started to thrive. We started to burn a lot of coal for electricity, started to drive a lot of cars, burn a lot of gasoline. And so it's kind of gone up and up and up really fast. And maybe it's slowing down. Hopefully we're getting to a peak here, although we had a drop during COVID, and now it's kind of spiked back up to pre-COVID levels. So we're not doing too great, but hopefully we're getting close to a peak. And so then, of course, we have the Paris Agreement where we want to stay below 2 degrees Celsius hotter than pre-industrial temperature. So we have a certain carbon budget, a certain amount of carbon that we can put in the atmosphere. And that's like our budget. And we can't go past that if we want to stay below 2 degrees. And so the IPCC report put together a couple of potential scenarios for using that budget. And so one that they looked at looks kind of like this. It's this green line where basically we have to get to peak global carbon dioxide emissions within the next couple of years. And they have to start falling quite fast, get to net zero around 2075 or so. You can see after that, they actually have it going negative, meaning that we're pulling more carbon dioxide out of the atmosphere than we're putting into it. There's some natural methods you could do that, like planting trees, like sequestering in agricultural soils, using farming methods that sequester carbon into the soil. So you're pulling carbon dioxide out of the atmosphere that way. And there's also technological ways to do it. We call it direct air capture. We're starting to see some plants doing this where they basically have big fans that pump air into basically a big filter that captures the carbon, and you got to do something with the carbon, either sequester it somewhere or use it in some kind of application. But in any case, that's one way, one pathway to do it is to get down to net zero globally emissions by around 2075, and then get to net negative after that. Or if you can't, or if we don't want to rely on this net negative emissions because we're not really sure what the technology is, how well it's going to develop, because right now it's very, very expensive to do. So if you can't rely on that negative emissions, then you have to get to zero even faster, which means this curve has to be even steeper. So you can kind of see the urgency of the problem. Like, it's actually the curve going down is steeper than the curve going up. So basically we have to transition our economy off fossil fuels faster than the economy started ramped up and relied on fossil fuels. And that's the 2 degrees Celsius pathway. There's also 1.5 degrees Celsius target. It's the kind of that more aspirational target in the Paris Agreement. So that would be ideally if we could stay below 1.5 or close to 1.5 degrees Celsius, then the pathway has to look even more aggressive. Again, we basically have to peak right away and then get very steeply emissions going down, 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 getting to net zero around 2050. And then the IPCC also relies again on a lot of negative emissions, a lot of pulling carbon dioxide out of the atmosphere. If you don't rely on that happening, then you have to get to net zero by like 2040, which is really not feasible. Right now, basically, there's a lot of countries that have net zero targets, but they're usually by 2050, like the United States has a net zero by 2050 target. China has a net zero by 2060 target. And so we're probably not going to be able to do better than that. Like, we're hoping countries can at least meet those targets, but it's unlikely they're going to be able to do better than that. So hopefully we can at least do better than this one and stay below 2 degrees Celsius and limit climate change damages that way. So the way we do that is through policy. So let's talk about policy. And the moment we're in right now is like super, super important. This is like a once in a generation opportunity. So what I've got here is I put together a chart of party control of the House, the Senate, the White House. And then this last one at the bottom shows whether one party or the other had full control of those 3 chambers at the same time. So you can see in the last 20 years, it's been pretty rare for one party to have full control, especially the Democrats. So the Democrats are the blue. And I mean, unfortunately, so caveat that my group, Citizens Climate Lobby, is a nonpartisan organization. We try to get both parties, members of both parties, to support climate policies. But right now, serious climate policy, if we want to pass serious climate policy, it's the Democrats are kind of the only game in town right now. I wish that weren't the case, but right now that is the case. So if you want serious climate policy implemented, you need Democrats in full control of the government, given the current status of our political system. And so that's only happened twice in the past 20 years. Once was in 2009, right after President Obama got elected. So Democrats tried to pass this bill called Waxman-Markey, named after the 2 co-authors. It was a carbon cap and trade bill, which basically putting a price on carbon and trying to address climate change that way. And it did pass the House, and then it got to the Senate, and there weren't 60 votes for it. So it was going to not pass a filibuster. And so Democrats didn't bring it up for a vote in the Senate, and it died a quiet death there. And then the next election, the Democrats lost control of the House, and they haven't regained full control of the government again until now. And so that's where we're at now, where they're trying to, again, do something on climate change, this time through the budget reconciliation process that we're seeing right now. And again, so this is like their first chance since 2009, which was a failure. So it's really their first chance basically in history, because nobody was trying to pass serious climate policy before then. And then just based on like gerrymandering and stuff, there's a very good chance the Democrats lose control of the House and or the Senate in 2022-23. And then because of kind of the composition of the Senate and the Senate races that are up in 2024, they're very likely to lose control of the Senate in 2024 to 2025. So again, this is like a very, very narrow window where like the party that wants to do something serious on climate change has full control and the capability of doing it. So like, this is it. And like, once they lose control of the House and or Senate, like because of the structural issues with rural parts of the country having advantages. It's basically like to get our emissions down fast enough, as fast as we need to. Like this is our shot. This is it right now. Like this is our basically our last best chance at serious climate policy that will meet the Paris targets, or at least meet our share of the Paris targets. So that's why it's so important. So we did have this bipartisan infrastructure package that had some climate stuff in it, so that was good. So that was passed by the Senate. It is currently kind of being held up by the House progressives as leverage to make sure that the reconciliation package also passes, but it has passed the Senate so far. So it had some good stuff. It had some investment in rail, in public transit, electricity transmission, which is very important because as you get more renewables, if you get, for example, a whole bunch of solar in one area and that area is sunny, and you have a bunch of solar in another area and that area is cloudy, you want to be able to transmit that extra solar from the sunny area to the cloudy area so that you can have a reliable grid. So long distance electricity transmission is very important. So it's good to see that investment in that. There's also some investment in research in nuclear, carbon capture, clean hydrogen, climate resilience, environmental remediation, which includes orphan gas wells. So orphan gas wells are a problem because they're like, it's like when an oil and gas company drills a well, they get the oil and gas out of it that they want to, and then they abandon it. And what they're supposed to do is cap it. So that because the problem is if they don't cap it, then it can leak methane, continue to leak methane into the atmosphere, and methane is a very powerful greenhouse gas. And the problem is that they are very often very poorly regulated. And so the regulatory agencies often don't check if the gas wells have been capped. And so often they get just abandoned by the oil and gas company, which is why they call it orphan, which is a really sad name because it's like the parent oil and gas company abandoned its oil well child, and so it's an orphan, and it's very sad. But these are really a problem. So we need basically investments to get somebody to cap these. So it's good that some of this environmental remediation money will go towards capping some of these orphan gas wells that are leaking methane into the atmosphere. So that's good. It's got some money for EV charging stations, not a whole lot, and some money for electric school buses, basically enough to electrify 3% of the school bus fleet, which is not a lot. But just kind of in a nutshell, the stuff in the bipartisan infrastructure package on climate is like a good start, but it's not really enough to make a big dent in our greenhouse gas emissions, which is why we need the climate stuff in the budget reconciliation package. So the deal with the budget reconciliation package, everybody's probably familiar with the rules now. It doesn't have to, it's not subject to the filibuster, and so you just need 50 votes plus the tiebreaker from the vice president to pass it. But anything in the budget reconciliation bill has to be primarily budgetary in nature, which is very tricky for climate policy because a lot of climate policy is based on regulations. And if it's regulatory in nature, then the Senate parliamentarian says, no, you can't put it in here, take it out. Which is what happened when, for example, in the first budget reconciliation earlier this year, Democrats tried to do a $15 federal minimum wage. Parliamentarians said, no, that's too regulatory in nature, take it out. And this budget reconciliation package tried to include some stuff on immigration. Parliamentarian again said, no, that's too regulatory, take it out. So that's a challenge for climate policy too. So the Democrats put together their outline at first of the climate stuff in what was initially the $3.5 trillion, what they wanted to be $3.5 trillion package. That is going to be trimmed down because Joe Manchin and Kristen Sinema don't like that number. But this is what they initially wanted to put in there. So they had a lot of investment in clean energy and EV tax incentives, stuff for investing in agriculture, wildfire prevention, and forestry to try to prevent all this carbon from being released into the atmosphere, try to do more sequestration of the carbon naturally. As I talked about, getting the federal government to buy clean technologies, making buildings more energy efficient. They wanted to make a clean energy accelerator to help research and development of new technologies, or at least fund organizations doing that research. A civilian climate corps is a cool idea to basically create climate jobs in things like forestry and things that would help tackle climate change. They proposed doing a price on methane pollution, which is interesting because, again, methane, powerful greenhouse gas, getting leaked into the atmosphere by these abandoned wells and by drilling in general of oil and gas. So really good idea to put a price on that so that it's not being pumped into the atmosphere for free to kind of dissuade oil and gas companies from polluting with so much methane. And a clean electricity standard was something that they wanted to put in there, which is basically saying that utilities have to get a certain percentage of their electricity from clean sources by a certain date. And I'm going to talk more about that because that's a big component. So how this all works is that, so they had that outline, and basically the leaders then task the different committees in the House and Senate with different portions. And they say, like, here's like the chunk of money that you can get. Here's what we want you to do. Go write the language, the legislation to accomplish these bits of our outline. So the most important committees in the House are Energy and Commerce, which again deals with stuff that's related to energy. So that's very important for climate stuff. Ways and Means deals with budgetary stuff. So very important for like tax incentives and tax credits. In the Senate, this is very similar. It's the Senate Finance Committee deals with tax stuffs and investment stuff. And the Senate Energy and Natural Resource Committee deals with energy stuff. The Senate Energy Committee is the one that's chaired by Joe Manchin, which is a little problematic because he is the least climate friendly member of this Democratic Senate committee. But at the same time, you have to get his vote on anything. And so it's not the worst thing, I guess, to have him crafting the Senate energy stuff because he'll craft it in a way that he can vote for it. So it's kind of a kind of good, kind of bad situation. So then once the committees finish writing their language, then it kind of goes out to the entire Democratic House and Senate populace. And then they have to like negotiate and make sure everybody, every single one of their members in their party in the House and the Senate is on board with voting for the entire package, because they have these narrow majorities where they basically, the House can afford to lose 3 votes, but the Senate can't afford to lose any votes. And so they have to make sure everybody's on board. And so the House will pass its version, the Senate will pass its version. Ultimately, the House is going to end up voting for the Senate version just because the Senate has zero leeway. Like whatever comes out of the Senate is what Joe Manchin and Kristen Sinema are willing to vote for. The House is willing to do more ambitious stuff, but that's why it's going to come down to the Senate, because like basically whatever Joe Manchin and Kristen Sinema are willing to vote for is kind of what's going to end up passing. So the Senate version is more important. The House version is kind of like, here's what the House wants to do. They are negotiating with the Senate to try to, influence the Senate version, but it's really the Senate version that's going to be the important part of the budget reconciliation. And there was actually a reconciliation earlier this year that I mentioned. The same thing happened. The House passed their version, the Senate passed their version, and the House just passed the Senate version. And the House version just ends up being like, here's what we would like to happen, but we are going to vote on the Senate version because there's no leeway in the Senate. They have 50 votes. So one important thing, so the House committees have moved faster than the Senate committees. And so some of the stuff has already come out of the House committees. And so one important thing that came out of House Energy and Commerce is the Clean Electricity Performance Program, which is how they're trying to get a clean electricity standard passed. Because again, the clean electricity standard is basically government telling utilities you have to get X% of your electricity from clean sources by year Y. It's usually 80% clean by 2030 is usually our target. But that's a regulation. So that can't pass through the budget reconciliation process. The parliamentarian will say, no, take that out. And so they tweaked it to try to make it budgetary in nature. So that's why it's a clean electricity performance program rather than a clean electricity standard. So what they did is create a financial incentive for utilities to increase their share of electricity, clean electricity every year, 4% per year. So basically, if they meet that goal, then the federal government will give them some money in the form of grants. So basically encouraging them, good job, here's some money to pay for your accomplishment of getting more clean electricity. If they don't meet that goal, then they get fined. And so you can see now this is a way to connect budgetary nature to this program. So that's kind of how they're trying to make it work. There was this group called Analysis Group, not the most creative name, that did an analysis of the CEPP, Clean Electricity Performance Program. So they said if we got to 80% clean electricity by 2030, it would create 7.7 million new jobs, add almost $1 trillion to the national economy, and raise $154 billion in tax revenue. It would actually also cost $150 billion to implement. So basically, it will be kind of revenue neutral in that sense, because you'll basically get the money back that you invested it in, but you get this boost to the economy and this boost to unemployment because you're investing this money in basically deploying a bunch of wind and solar energy and other clean technologies. And so basically that investment creates jobs, and then those workers who have new income are then spending it, and it creates this economic boost. So the question is, will Joe Manchin go for this? Will he nix it? Will he water it down? Will the Senate parliamentarians say that this is sufficiently budgetary in nature? Or will the Senate parliamentarians say, no, this is still too regulatory in nature, you can't do it at all? These are all very big question marks that nobody knows the answer to right now. So that's kind of where we are right now, is that this proposal is out there. Joe Manchin is in charge of working on the Senate version. He will probably water it down. He might change that 4% to 3% per year. We don't know. And then we don't know if the Senate parliamentarian will let it happen at all. So the Energy and Commerce Committee did some other stuff. They put various investments, or proposed to do various investments in home energy retrofits, home electrification, EV infrastructure, replacing heavy-duty vehicles with electric vehicles, electricity transmission, kind of bumping up the investment in electricity transmission further, decarbonizing federal buildings and federal fleets, creating a green bank, which is kind of a cool idea, where you got this green bank, and then the green bank invests in companies that are developing clean technologies. So basically creates this incentive and pot for green technologies to use. Some money for low-income solar, some money for environmental and climate justice programs, which is interesting. And this is where kind of the fee on leaked methane from oil and gas operations comes in. They want to use the EPA to impose the fee when oil and gas industries leak methane into the atmosphere. So then the House Ways and Means Committee also kind of released what they want to do. So they have a whole bunch of stuff in there, a lot about tax credits and tax incentives. So they want to extend tax credits for clean energy. They want to create a bigger tax credit for EVs, up to $12,500 per EV. So there's like a chunk of money for any EV, and then it gets a bigger tax credit if it's made in the USA. And it gets an even bigger tax credit if it's made in the USA by union workers. So if you add those all up, if it's made in the USA by union workers, they can get as much as $12,500 tax credit. And they're limiting that to sedans that are EVs that are under $55,000, SUVs under $69,000, and trucks under $74,000. So for example, you don't have like a rich guy buying a Tesla Roadster getting this tax credit that they don't need. There's also the electric bike tax credits, 50% tax credit for electric bikes that are under $8,000, which is pretty cool. It's not a huge tax credit, but it's something. They want to extend the current tax credit for carbon capture and storage and create a new tax credit for direct air capture of carbon, which is the one I talked about, where they pump the air into the filters and capture the carbon. So trying to encourage that. Tax credit for transmission lines. Again, anything improving transmission lines is good. They want to do a new tax credit for existing nuclear power plants, because existing nuclear power plants are a basically zero carbon source of electricity that's very reliable. But we're having a lot of places like California starting to kind of phase out older nuclear power plants for various reasons that are not necessarily taking climate change into account. Because when you phase those out, then you have to replace them with something. And oftentimes it gets replaced with natural gas, which then you're replacing a zero carbon source of electricity with a carbon intensive source of electricity, which is counterproductive for climate change. So they're creating this tax credit to kind of help existing nuclear power plants stay in operation. They have they're proposing this sustainable aviation fuel credit. So if somebody invents a new source of aviation fuel that cuts emissions at least 50% for what's in jet fuel right now, then they will get a tax credit for that, which is good because aviation is a really tricky one to address, because we can have for short distance flights, you can do electric planes, but that's hard to do for long distance flights because batteries are heavy. So we need some kind of fuel alternative. So if we can incentivize developments of new technologies there, that's really good. Tax credit for clean hydrogen, which is actually a potential source of clean fuel, and then tax credits for energy efficient homes and for environmental justice programs. And I think that was it. Yeah. So a lot of stuff in there. But again, that was in the $3.5 trillion plan. So some of that stuff is probably going to get cut. So there's going to be a big fight over if they have to trim that number down from 3.5 trillion to like 2 trillion, then what exactly gets cut. And, I know there's a lot of people in Congress who are trying to minimize the cuts to climate stuff. So we'll see. Hopefully they're successful with that. Because the issue is the Biden administration updated we call it the nationally determined contribution, the NDC, which is America's portion of the Paris Pledge to stay below 2 degrees Celsius. So our portion of that is now that we want to, on the way to getting to net zero emissions by 2050, we need to get to 50% below 2005 levels by 2030. So that's kind of our more short-term Paris target. So there were 3 analyses of what's currently in the outline and the proposals of budget reconciliation for the $3.5 trillion part to analyze how successful they would be at reducing emissions. And all 3 analyses basically said what's currently in there isn't quite enough to get us to 50% below 2005 levels by 2030. So this is from Senate Majority Leader Chuck Schumer's office. And they have this nice pie chart kind of breaking down their numbers. And so you can see they're saying, how do we get to 45%? So their analysis is that we'll get to 45% below 2005 levels by 2050. So most of the way there. And then their argument is that like individual states like California and New York have their own climate policies. So maybe that'll get us the extra 5%, maybe not. So anyway, they break it down. So they said the biggest chunk of basically the most effective policy in the budget reconciliation outline is the CEPP, the Clean Electricity. It was called Payment Program. Now it's called Performance Program. Plus tax incentives for clean electricity, plus tax incentives for clean vehicles, EVs, plus that methane fee I talked about, the fee on leaked methane, plus some stuff for conservation of forests and agriculture to get them to sequester carbon. So those are kind of the 4 biggest chunks of how they believe that their budget reconciliation outline will get us to 45% below 2005 levels by 2030. So not quite to 50%. And there were a couple other analyses. One was this group, Rhodium Group, which is an independent research organization, where they looked at those 4 big categories, the CEPP, Clean Electricity Performance Program, the tax credits for clean electricity and EVs, the fee on methane, and the agriculture and forestry funding to do carbon sequestration. And so Rhodium estimated that those 4 big categories would get us to 39% below 2005 by 2030. So they're not including some of the smaller ones in the package and in Chuck Schumer's office's analysis. So if you include those, then it's pretty consistent. It's probably about the same, about 45% below 2005 by 2030. So they're in agreement. We're not quite to the 50% that we need. And there was one more group called Resources for Future, RFF, another independent nonprofit research group. They looked at the CEPP, the tax credits for clean energy and EVs, and they also looked at a carbon tax because the Senate Finance Committee, they haven't released anything yet, and then it might come out this week. They're working on it, but they leaked that one of the things they're considering for funding and for climate is a carbon tax. So basically RFF said, okay, well, if they get a carbon tax in there too, then what will the emissions cuts look like? So what they found, first they looked at if reconciliation like totally fails. So that's your worst case scenario, like say Democrats get in a big fight and they don't pass anything. So right now we're at something like 17% below 2005. So their estimate is that right now we're going down about 1% per year, just from renewables replacing coal, basically. So we keep on that rate. By 2030, we'll get to about 23% below 2005, which is basically a little less than halfway to our Paris target. So we're not going to be anywhere near our Paris target unless we get serious climate policy implemented. If we just did the Clean Electricity Performance Program plus the tax incentives for clean electricity and EVs, that would get us to 39% cuts by 2030. So pretty consistent with the other analyses. If we just did a carbon tax, a pretty kind of a modest carbon tax, that alone would get us to 44% below 2005 levels by 2030. And if we did all three of those, the Clean Electricity Performance Program, the tax incentives for clean technologies, and a carbon tax, then we would get to 50% below 2005 levels by 2030. So basically, we need to do all those big things, although they're also not including some of the smaller stuff like the agriculture and forestry and other investments. So we could actually potentially do better than 50%. We could actually surpass our nationally determined contribution if we do everything that's currently in the package. Although, again, it's potentially going to get cut. So that's the good news, that we could potentially get there. So I wrote about this for the Citizens Climate Lobby blog. I made an analogy to the Avengers, the last movie, the Endgame, where, all the Avengers get together and they're about to fight Thanos and his army, and they're about to try to save half the life in the universe. And then Captain America is all like, Avengers, assemble. And so the idea is that we need every single climate policy and every different climate advocacy group to get as much different climate policy into the budget reconciliation as we can, because basically need everything we can get to get from our current level of 17% cuts to 50% cuts within the next 8 years. It's like a really steep change that we need to do. And so we need everybody to do everything they can. And again, this is like our once in a generation opportunity. So like right now we need everybody pushing as hard as they can to get members of Congress to put as much climate policy into the reconciliation bill as we can. So I'm going to briefly talk about pricing carbon, because that's what our group is. The Climate Lobby is, that's kind of our key policy that we support, and then we'll move on to questions. So the reason for carbon pollution pricing is pretty simple, that pollution shouldn't be free. So right now, when we burn fossil fuels, the polluters don't pay for the pollution. The carbon dioxide goes into the atmosphere, causes climate change, causes all the extreme weather events to get worse that we talked about, the droughts, wildfires, heat waves, hurricanes, floods. Those all get worse, and then we as taxpayers pay those costs of those worsened extreme weather events instead of the polluters paying for the costs. So you fix that, which economists call an externality, that the costs are external, not reflected in the price of the product. So you fix that by putting the price on carbon pollution. Because right now, by paying for all these extreme weather events getting worse and worse, we're basically subsidizing the fossil fuel industry like trillions of dollars per year by not forcing them to pay for it. The challenge is that lower income households spend a bigger proportion of their income on energy than higher income households. So if you just put a price on carbon pollution, it actually hits lower income households the worst, hits them the hardest, and that's not what we want to do. We don't want to put the burden on lower income households. And so the way it's usually proposed in policy to address that problem is through taking some or all of the revenue that's generated from the price on carbon and sending it back to households through regular dividend or rebate checks. So you can either send that back to just lower income households or lower and middle income households, or to everybody, depending on how the policymakers prefer to do it. The issue is the more money you send back in the form of these dividends, the less money you have. If you're doing it, for example, in reconciliation, their issues, they're trying to pay for everything. And if you have a carbon tax, that generates revenue that you can pay for other stuff. But the more of the revenue you send back to households in the form of these dividend checks, the less revenue you have to pay for the stuff in the reconciliation bill. So it's this balancing act. How much do you want to send back as dividends, and how much do you want to use as a pay for? So as I mentioned, we have this issue of lower income households paying a disproportionate percentage of their income on energy bills. So I put this together this chart of if we had a pretty significant carbon tax, $75 per ton, then this is broken down by how much the average household in each income group, from the poorest 20% of households to the richest 20% of households, how much their average annual bills would go up due to energy prices rising because of the carbon tax. So you can see basically the wealthier you are, the more you're paying, which makes sense because the wealthier you are, the more stuff you buy, the more you travel, the bigger your carbon footprint is. But again, if you're a lower income household and on average you make $36,000 a year, then that extra almost $1,000 a year in energy costs is a really big deal. Whereas if you're in a wealthier household making $230,000 a year, an extra $2,000 a year in energy costs is not a big deal. So there's that problem. One way to do it is just to take all the revenue, send it back equally to all taxpayers. If you do it as a revenue neutral way, take all the revenue, send it back equally to households, then everybody gets a dividend check that looks something like that. So you can see the lower income households, their increased energy costs are less than the check that they get, and vice versa for higher income households. And so it looks like this, where lower income households on average actually get a net income out of it because they're getting these checks that are bigger than their increased energy costs. Vice versa for the wealthier households, middle income households come out roughly even. And this is again is in the scenario where we take all the revenue and send it back equally to households. Probably what the Senate will do is return the revenue to most households because they don't want it to violate Biden's pledge not to increase taxes on individuals making less than $400,000. So most of this will still be accurate. But yeah, the idea then is that you're actually incentivizing people to have a low carbon footprint because also these wealthier households, like they have this increased cost. Maybe they don't want to pay that increased cost, so maybe they will put solar panels on the roof and buy a Tesla and decrease their carbon footprint so that this bar gets smaller and smaller and smaller as their carbon footprint gets smaller. And that's the whole point, is creating the financial incentive for people to decrease their carbon footprint. So then as everybody reduces their carbon footprints, then we're starting to address the climate problem. All right, so last slide. What can you do is the question I always get. And the main thing you can do is become engaged in the climate problem. So basically try, if you can, to join a climate advocacy group. So I kind of categorize these in two different groups. The top ones are more oriented towards climate and environmental justice. They tend to be more rigid in that they will oppose climate policies that they don't think are sufficiently addressing environmental climate justice issues. So Sunrise and 350 are kind of the primary ones there. And then there's ones that I call more pragmatic that are just kind of trying to work within the system to get done what we can. So like my group, Citizens Climate Lobby, we're working for the carbon pollution tax. The Sierra Club is another good example. So just two different categories, both doing important work, just taking a slightly different approach toward it. That both are very important approaches. One trying to get the most ambitious and effective climate policy possible, and these ones just trying to get the most pragmatic climate policy passed. So I'm going to stop there and take questions. I put, again, our link, cclusa.org/white-house, because we're trying to get, our goal is to get 20,000 emails sent to the White House, encouraging them to, because the issue is right now they're trying to figure out what to cut to decrease the overall amount in the budget reconciliation package. So we want to make sure they know as many constituents as possible voice their opinion that we don't want to cut the climate stuff. So make sure you keep the climate stuff in there. So it's very important right now to have as much contact of the White House and members of the Senate as possible. So if you go to the cclusa.org/White-House, we have a nice, easy form where you can either type in whatever you want, or it already says, there's already populated text in there that says, please keep a price on a carbon in the bill. So again, we're at like 13 or 14,000 emails to the White House so far. We want to get up to 20,000 by the end of the week. So as many people as could go there and push the White House to push Congress to keep a carbon tax and or other climate provisions from getting slashed from the budget reconciliation. As many people as can do that, the better, because they need to hear that from their constituents that we don't want to cut the climate stuff. All right, so that's enough for me. I'm going to stop and take some questions if there are any.
Wow, thank you so much, Dana. That was awesome.
Oh, thanks.
Wow, what a tour de force.
Thanks.
Oh, yeah, Mike, I agree.
Are there any questions
Yeah.
anywhere? I actually have one. I just found your analysis, the science, so not only compelling, but so easy to understand and so forceful. And my question is, how do we get that message out to everyone? All you need to do is hear it and see it, and you're on board.
Yeah, I mean, that is a challenge. I mean, the good news is that the majority of Americans like are on board with like wanting to do something about climate change. So I think the majority are in like the categories are concerned or alarmed. So that's good that most people like are aware of the problem, understand the urgency of it, and want to do something about it. There is like a section of the population that is still not well informed, they're disengaged or just like cautious about it. So those are the folks that it would be good to reach. So that's just a matter of, if you know any of those people, try to talk to them about climate change as much as possible. Like there's good research that like the most important thing you can do is like about to increase awareness is just to talk to people about climate change, because most people just don't talk about it that much and most people don't hear about it. And so talk about it with people, try to encourage people to get engaged in these climate advocacy groups. Because yeah, I mean, we have the majority on our side. It's just a matter of getting those people to urge their members of Congress to do something about this problem that they're concerned about. And, the more people we can get in these categories of wanting to do something about it and encouraging their members of Congress to do something about it, the better.
Thanks so much, Dana. I wonder if I can ask you just to follow up on Barbara's question, because there are big controversies. And there's this book that came out in April by an NYU academic named Stephen Koonin. Can you just offer us some perspective on that particular piece? Because it's different in terms of his background than others who I would say are more resistant to the issues that you're talking about.
Yeah, so Steve Koonin, he's a physicist. The Obama administration brought him on basically to get a contrarian voice because they didn't want to have everybody with the same opinion in their administration. And so now he's kind of milking that as like, I was an Obama scientist and I think that climate change isn't a big deal. But he's not a climate scientist, he's a physicist. So he's not an expert in the subject. And a lot of stuff he says is wrong and or misinterpreted from the scientific research, or a lot of times it's just cherry picked from the scientific research. So it's like one paper that says one thing and ignore or take it out of context, or it's just kind of classic misinformation that we've been dealing with for a very long time now. So I can put in the chat, my colleague at Yale Climate Connections, Mark Boslow, did a nice kind of analysis debunking of his book. I'll try to pull it up real quick and put the link in there. So that's a good reference to use. But, just in general, like it's important to bear in mind, like it's one book by one guy who's not even like a climate expert. And so like a lot of people latch onto that because it's kind of confirmation bias. It tells them what they want to believe. It's like, here is my expert who tells me that climate change isn't a big deal. But, the vast majority of actual experts disagree with him. And, the reasons he's wrong are just classic, like cherry picking, taking things out of context. And yeah, so yeah, just in general, he's kind of full of it. See if I can, here we go. I got it. So I'll put the link in the chat to the article.
Thanks, that's great. A critical review of Stephen Koonin's.
Oh, there was a hand up just to Mike.
Hi, yeah, thanks for taking my question. I had the opportunity over the weekend to talk to a lot of people about the carbon tax, and the people I talked with, it was everything from somebody who saw me wearing a sign that said, ask me about lobbying for climate policy, and they wanted to tell me all about why that's a terrible idea, to people who were enthusiastic and wanted to learn more. So I had a lot of slips in hand, gave people information with a QR code to link them to their representative and call their senator. And I put the link to Biden's, like the 13,000 that hopefully I got a couple of those. But the thing I noticed the most that I just want to give feedback on and ask what you would answer when you get this question is, if China's not going to go along with us, what's the point? It's already over. Like I got that defeatist kind of response a lot. And people are worried about their jobs, and people were worried about, anyway, I'm sure you've heard all that stuff. I'd just like to get your take on it. Thank you.
Yeah. So the blame China, there's kind of two ways to go about it. So it kind of depends on how much time you have to talk to the person. But so one way to go about it is to point out that historically, if you look at cumulative emissions, the United States has a much larger portion of historical carbon emissions than China does. And even today, we have I think it's twice double their per person carbon emissions. So they have more overall carbon emissions, so they have a bigger population, but we still have more per person carbon emissions. So before you go about blaming China, we have to get our own mess in order. And also as we get our own mess in order, then we're setting an example for them to follow. And then, so that's kind of one way to go about it. Another way to go about it is to point out they already are doing a whole lot. They've been deploying tons of wind and solar and batteries and EVs. And they've said they're going to peak they're aiming for peaking their emissions by 2030, and they have set a net zero emissions target by 2060, which is slower than ours, but also they're still their economy is still rampant because they've been a developing country. So that's actually a really ambitious target. So their leadership recognizes the problem, and they are trying to do something about it, and they're taking concrete action. And at this point, they're taking more action than we are. They are phasing out coal, they're deploying all these renewables, they have federal policy, it's authoritarian policy, but it is nevertheless federal policy to address the problem. Whereas the United States, so far, we have no federal policy. So if people start to say, well, what about China? China is doing more at this point. They have further to go than we do, because of their population, but they're doing more to get their emissions going in the opposite direction than we are from a federal level right now. So there's a couple of different ways to address it. We're more responsible for the problem, and we have to show leadership, and they're doing more than we are, arguably. So there's a couple of different ways. If I only had a few seconds, I would probably say just point to all the stuff that they're doing. They're doing so much right now. They're also implementing cap and trade systems. So they're doing carbon pricing in China. So that's something that we're not doing yet, although hopefully we will in budget reconciliation. But they're doing a lot right now. So that's kind of what I would focus on.
Yeah, and for that type of voter or person who's interested in learning but is still on the fence about that and feels that we're going to fall behind economically, can you just say, well, we are going to fall behind economically because we're not getting in the game? Yeah,
that's another point, is that the economy is transitioning towards a green economy. Whoever gets the upper hand in terms of these clean technologies is going to have the upper hand in the future economy. So whoever is doing more solar and wind and batteries and EVs, they're going to be the economic powerhouse in the future, because that's where everybody is going. Europe, China, US, every country wants to get these clean technologies. So whoever's investing in that's going to be the economic winner in the future. So that is another point. That's one reason that China is making this big transition, because they recognize they want to be the economic powerhouse. They know solar and wind and EVs are the future, and so they're investing in that.
Thank you.
Sure.
It just seems to me that to get those people who are on the fence, or the people who are, this is not my issue, hit them with self-interest. As you just mentioned, China, they're going to be the powerhouse. We have to get on it. Or even, the farmers in the Central Valley. This is hurting you in your pocketbook.
Mm-hmm. Yeah, I think climate change impacts is a good way to do this, which one of the things, my pet project at Citizens Climate Lobby, is I'm creating slide decks of climate impacts for each region. So what I did today was a Southwest region, but I've got one for the Great Plains, and I'm doing all the other regions, because there's every region is hit by some sort of climate change impact. And there's actually a paper that came out today that I think it's 85% of people in the world have already been impacted by climate change in one way or the other. So we're all feeling the impacts already. We might not realize it, because you might just think there's a lot of flooding. Maybe you don't connect that to climate change, but that is connected to climate change. So if you help people understand that will at least make it more likely that they'll want to do something about the problem. Because if they see I am already being impacted. Because there's also polling showing asking people have you been impacted by climate change? And it's like less than half of people say yes in America. And it's actually like pretty much everybody has been impacted by climate change at this point. Like you're breathing the wildfire smoke, you're getting the flooding or the droughts or the flood or the heat waves or the hurricanes. Like there's something that's hitting you. And so people need to make that connection for sure.
Yeah.
It was hard. Some of the people I spoke with were truck drivers, and they had a very strong stance, you know.
Well, you know, electric trucks are becoming a big thing. So Tesla's coming out with an electric big transportation truck, and there's a couple of different companies. So, you know, hey, wouldn't you guys like to be driving some cool electric trucks instead of a gasoline truck? That's kind of hopefully the answer is yes to that.
A satellite turn event at a truck stop. It just came to a vision. The middle of like Winnemucca or something, you know, just has to be out there. Catch people when they're on I-80 and they've been driving for a long time. They might be more vulnerable.
Right.
Yeah, I think it's great how to get that message out there. Climate Reality does a really good job of training people to speak, you know, who are from all different walks of life. They aren't necessarily professionals like Dana Nuccitelli, but they are, you know, like people like me that get training from Climate Reality, and that's where I think they do a very good job. It's Al Gore's, you know, it's his gig. It's a really great way for people to realize that all these events that people think are unrelated are actually related. And I think that the Climate Reality training is one of the best places I've seen that helps a person see like, oh, that's related to that. All the problems you think you have, you know, are related. And I'm going to push this letter writing campaign a lot with my tUrn mailing list and see if we can get a little, you know, light up the grid a little bit here at SCU and with the other partners to tUrn that are in other Jesuit universities. It's a great campaign you guys have organized, and I want to just commend you for doing so much in all these different venues, but especially this citizens climate lobby right now in history. The fact that you're there and we have this democratic, fragile, weird possibility of a majority for voting for this issue. That couldn't be better. So I don't know. I have a lot of hope. I mean, I tend to be also like alarmed at my own ability to alarm people. I do think that it's important for people to know that at 4 degrees, when people are talking about how bad things will be at 4 degrees, I don't think we'll be living at 4 degrees. I mean, we can't sustain at 4 degrees. So I think it's really important for all these people writing these reports when they say, you know, oh, well, you know, the economy will be really bad at 4 degrees. Like, I feel like, well, it'd be bad because there'll be no trees and no oxygen. And you know, just that's pretty much, the forest won't survive at 4 degrees. And if forest is not there, then we're not here. So there's something about people not understanding how close 1.5 and 2 are to a really unlivable situation, except with like maybe some, you know, pockets of people. And I don't know, there's always got to be some kind of thing that happens with humans. But, you know, to me, some of the reports go off the chart, but act like they're still on the chart.
Mm-hmm. Yeah, I mean, 4 degrees, I describe it like it would almost definitely be a catastrophe. Like it'll be, society would be completely different, and it'll be miserable. I mean, the good news is like that is really, really worst case scenario. Like right now, if we follow through with all the current policies that have been implemented around the world, then we're on track for about 3 degrees, which would still be really bad, but at least it's not 4. So we're kind of moving in the right direction. And then if we follow through with all the pledges, then we get to like 2.5 degrees. So we're starting to kind of inch towards 2 degrees. But again, that's if like the people who are trying to delay and undo climate policies don't get their way. So like like at this point, 3 degrees is like worst case if like climate policies don't get unraveled, but like that's still a possibility. So
I just don't think people realize that at 3 degrees you won't be able to drive a car down the street because the wind will be so strong it'll blow you right off the road. I mean, you know, like the way the storms are now, the way cars are made and the way roads are made, assuming that's a continuous thought that there are still cars and still roads, you know, at some point the engineering and the assumptions of gravity and the mechanics don't work when the storms get so strong, and suddenly 75% of the cars people own are undrivable because of this extreme weather, you know. So like there's things that I don't think people have calculated when it comes to really the calculus, when it comes to like looking at like all that stuff under that curve, and the compounding things. And it's been experienced already by people in places, for whom the jet stream is off, and they get those superstorms that circle around, and they can't do certain things you would think you could do, like walk down the street. So I think people talk about 3 degrees like it's going to be a really hot time. I'm going to be boiling. I'm going to wear shorts. I'm going to wear shorts every day. And I think it's different than that. It's really different than that.
Yeah, I would have some severe impacts. Like there would probably have to be like coastal retreats and things like that. But it's easy to say, oh, we'll just pull away from the coast. And like if you live in New Orleans, that's like a whole different thing than like somebody who lives in Colorado. And it's like, oh, just pull away from the coast. Like that's where people live. And like how do you even manage that? So yeah.
So I think our fight for the 1.5 is the most decent one, and that may mean everybody has to move into more climate action than we ever even imagined.
Yeah, it's going to take everything that we can implement, especially right now.